Learning objective of this video. By the end of this video lesson, you should be able to understand about operating system structure. The following contents we are going to discuss in this video lesson. The first one is operating system structure, simple structure, purpose of simple structure, advantages and disadvantages, multi-programming and multitasking. Simple structure. Today in this video, we are going to learn about simple structure, which is one of the structure in an operating system. We know the importance of operating system in computer. It helps the user interact with the hardware. With this, without operating system, things can become very complex. So, the operating system must be well engineered and structured so that it functions properly and efficiently. So, the simple structure is one of the structures is used to design an operating system, which we will see in depth. Simple structure was used to design some initial operating systems. The operating system is designed in the beginning with the desired using the structure. See, this is the operating system simple structure. MS-DOS is an example of such a system. It was designed to be implemented by only few people and designed to give more functionality in less space. So this structure was not well defined, but still the operating system got so much popular that the structure was used in many systems at the time. Following is this diagram for simple structure. Let us study and simplify the diagram. The diagram looks like layered structure, but it is a simple structure. At the top we have application program. These are programs where users directly interact with them. For example, if you want to write a document, Microsoft Word is the application program that you use. If you are using Windows OS, it provides the application to the end user. The second from top is resident system program. System programs are basically the bridge between user interface and system calls, like for example, file manipulation. When we create a legal file system, program gives a system call, and after giving system call, file manipulation of system files are done, like creating a file with a leading file and several. There are many system programs, file manipulation is one of them. The third from the top is MS-DOS device drivers. The device driver is a computer program that operates more control the particular device attached to the computer. For example, if you connect a card reader to the computer, how will the operating system or user interact with it? We interact with the software using user interface, but we cannot do the same with hardware. The device driver provides a software interface to hardware device. With this interface, operating system and the user can interact with the hardware without any precise details about the hardware. The last one is ROM BIOS device drivers. This layer can be considered as the hardware. The BIOS stands for Basic Input Output System. The driver is required for BIOS are stored in ROM. There is bare only memory on motherboard. These are the basic drivers used to start a system. These are the layers of simple structure. Let us see the connections. The application program can communicate directly with the resident system program and the hardware, that is the ROM BIOS device drivers. The resident system program can communicate directly with the MS-DOS device drivers and hardware. And at last, MS-DOS device drivers can directly communicate with the hardware. Here we can see a systematic approach, but also we see that each one can access the hardware directly without any restrictions. Let us take an example. If you need to withdraw the cash from bank, then you visit the bank, fill it withdrawal slip or for check given to the employee. He will make an entry, checking it and pass it to the cashier. Then the cashier will get the money from bank locker and then give it to you. See, this is a systematic approach. What if everyone has access to bank locker? Anyone can directly access the bank locker without any restriction. This is definitely not a good option. Similarly, if every application program has direct access to hardware, malicious or harmful program may take advantage of this. So this makes the system vulnerable. The time when it was designed, the hardware was also not up to the mark. Therefore, the developer says no choice. Let us see the advantages and the disadvantages of simple structure. The advantages of simple structure here was it will provide the more functionality in the least space. The next one is less complex. It was not that complex in comparison with our modern operating system, but still it provided great functionality. That was the reason it got so popular. Talking about the disadvantages, the one which we discussed earlier, as application programs were able to access the hardware directly, direct access to hardware made it vulnerable to malicious program. And also another advantage, if application program would get crash, the whole system got affected. So we are done with simple structure. In this lecture, we'll be studying about operating system structure and we'll be mainly talking about multi-programming and multitasking. So operating systems, they vary greatly in their makeup internally. So we have different kind of operating systems is that we know like Windows, Ubuntu and so on. And these operating systems, they vary in their makeup internally. Internally, the way they are made may be so much different, but they also have so many common things in them. So we'll be seeing about the common things that every operating system must be capable of doing in this lecture. So we will be discussing about the commonalities. The first two things that every operating system must be capable of doing are multi-programming and time sharing or multitasking. So these are two very important topics we should be seeing in this lecture. So first let's talk about multi-programming, then we will see about multitasking. The multitasking is also known as time sharing. So coming to multi-programming, the name itself, we must have understood that multi-programming means the capability of running multiple programs by the CPU. A single user cannot in general keep either the CPU or the IO devices busy at all times. Now if you are not having multi-programming, what will happen is that a single user will always keep the CPU, all input-output devices busy at all the time. That is because when a single user wants to execute a particular task, it will use the CPU. So until and unless the task is completed, no other users can use the CPU or the IO devices because it is not capable of multi-programming. But in multi-programming, that will happen is that it increases the CPU utilization by organizing jobs which are code and data so that the CPU always has one to execute. So that means in multi-programming, what we are trying to do is we are trying to increase our CPU utilization because the CPU is capable of executing multiple programs. So let's see how this works. So in this diagram, we have a job pool, more number of jobs available, and the memory layout of the multi-programming system. So first of all, understand what is a job. So job is something that has to be executed, which may contain codes and data. So here we have a job pool which consists of all the jobs that entered the system. So all the jobs has to be executed. They are kept in a job pool like this. And then here we have the memory layout programming system. So on the top we have the operating system, and these are the jobs are loaded into memory. So we cannot load all the jobs in the job pool into the memory because we don't have unlimited memory, or memory is limited. So why memory? I mean the main memory, RAM. So here in this example, we are having 512 megabytes of RAM over here. So you are not able to load all this to the main memory. So a subset of these jobs, for some of these jobs are loaded into the memory. So what is example? We have loaded job 1, job 2, job 3 and job 4 into the memory. Now this operating system has to help in executing these jobs by assigning the CPU to these particular jobs. So if I don't have this multi-programming, what will happen is the job won't let starts executing and is using the CPU now until and unless the job one finishes its execution completely. The other jobs cannot use the CPU. So it said that job 1 was running on the CPU and then it has to use some other resources in the course of execution. Let's say the IO devices. Now in job 1 goes to use the IO devices, the CPU is not used and CPU just stays idle without being used by any other jobs. So that is a very inefficient way. So in multi-programming, what happens is that, let's see the example again. job won't start executing again is using the CPU, and on the course of its execution of job 1 tries to use the IO devices. So when it goes for using the IO devices or any other resources, the CPU is released by job 1, this job 1, and then the CPU, instead of remaining idle, it can be used by another job. Let's say job 2. So job 2 can use the CPU until job 1 finishes its other on or our device operations. And once the CPU back, so job 2 will be using the CPU, and again if it's a jobs 2 wants to go for using some other resources and does not need the CPU at a particular time, then the CPU again, instead of remaining idle, can be used by job 3 and so on. So in this thing we see that the CPU does not remain idle. Whenever a particular job does not want to use a CPU, the CPU can be utilized by another job. So this is a very efficient system or an efficient way of executing. So that is what multiprogramming is mainly about. So we see that for operating system to be efficient, it should be capable of this multiprogramming. So we can also relate this multiprogramming with our day-to-day life. So let's say that, for example, there is a lawyer who has different clients under him. Now the lawyer is not taking care of only a single client at a particular time. Let's say that he is taking care of one client, and when the client case is waiting to go on a trial, or when the lawyer is waiting for his paperwork to be done, he does not simply keep waiting for that single client, but at the same time he can take care of another client that is under him. So in that way he is utilizing his time and resources efficiently. So that is what we do in multiprogramming. We are trying to utilize our CPU efficiently. Now a multiprogramming system provides an environment in which the various system resources like CPU, memory and peripheral devices are used efficiently and effectively, but they do not provide for user interaction with the computer system. So in multiprogramming system, it makes sure that all our resources are used effectively, but they did not provide for user interaction with the computer system. So that brings us to the next topic, which is multitasking or time sharing system. What is the time sharing or multitasking system? Let us see how it is different from the multiprogramming system. So first of all, the CPU execute multiple jobs by switching among them. This is almost same like the multiprogramming system. This first point, it says that the CPU execute multiple jobs. They have multiple jobs as we saw above, and then instead of executing only a single job at a time, what the CPU does is it switches between the jobs, and then the switching occurs so frequently that the user can interact with each program while it is running. Now this switching happens, it happens so quickly that the user can interact with the program while it is running. So this was something that was not there in the multiprogramming. So here the user can actually interact with the program even while it is running, because the switching between the jobs takes place very fast in this time sharing system. And then this time sharing requires an interactive or hands-on computer system which provides direct communication between the user and the system. So this was something that is not there in the multi-programming system. But the last point that we discussed, in the time sharing system, there is a direct communication between the user and the system. And its time sharing system, as the name suggests, the time shared operating system will allow many users to share the computer simultaneously, so that the computer system is shared among many users simultaneously in this time sharing system. So let's see how this works. See, in this example, this multitasking of time sharing is functioning here. The central CPU sharing the resources with these terminals and the central storage and shared printer is everything. This is the time example for time sharing environment. This is another one example of multitasking on a desktop system. Is connected with the World Wide Web, and it performing some process, some kind of music system and all. It also process the execution of emails, and also it carries this operating system will perform the antivirus. So now this summary about this video lesson. In this video lesson, we discuss about operating system structure, simple structure. It is used to design initial operating systems. Example, MS-DOS. The scope was limited. It more functionality in less space. The purpose of simple structure is application programs, resident system programs, MS-DOS device drivers, and ROM BIOS device drivers. Advantages: the more functionality in least space and less complex. Disadvantages: direct access to hardware made it vulnerable to malicious program, and also another disadvantage is if application program would get crashed, the whole system got affected. The commonalities of this operating system structure is multi-programming and multitasking. The multi-programming is nothing but multi-programmed systems provide an environment in which the various system resources are utilized effectively, but they do not provide for user interaction with the computer system. And multitasking, the CPU executes multiple jobs by switching among them. The switches occur so frequently that the users can interact with each program while it is running. Now you can take up this QR code for testing your skill about this video lesson. Thank you all for listening patiently in this video lesson of operating system structures.